Hello everyone, welcome to my YouTube channel. In my last video, I have discussed about the definition of nilpotent matrix, some of its properties and its examples. And I have also discussed about the definition of periodic matrix. Sometimes the concepts related to periodic matrix is also asked in the competitive exams, so that's why I told you about the definition. Today we will discuss a special type of matrix that is called vondermonde matrix. So, a matrix with geometric progression in each row is called vondermonde matrix. So, how we can understand that this is a vondermonde matrix? So, a matrix of type 1 alpha alpha square and dot 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 alpha to the power n minus 1. If you see the row of this matrix, the first row is present in GP series with the common ratio alpha. If you see our second row, this is also in GP with the common ratio beta. And in the last row, and if you see the last row, it is also in geometric progression with the common ratio delta. So this kind of matrix are known as vondermonde matrix. In order to understand that this matrix is vondermonde, you have to just check the rows. If the rows are in GP series, you will say that this matrix is vondermonde matrix. Now the question arises that how we can determine the determinant of such type of matrix. So we just took the second column and take the last element delta minus the second last element, suppose it is delta 1, and so on. We'll proceed in this manner, that is second last to third last and so on. At the last we take beta minus alpha, and then we just take the last one, that is alpha minus delta. So this kind of matrices have determinant this. I will take one example and then it will be more clear. So I have considered one example of a 3 cross 3 vondermonde matrix. Now if I want to determine the determinant of this matrix, how we can approach it? So just took the second column and just subtract the last entry from the second last entry from the last entry. So what will we get? x3 minus x2. And then this one minus this one, x2 minus x1. At the last, we take the last entry and then minus first entry, that is x3 minus x1. So here you will also change delta minus alpha. So that's the way by which we can calculate the determinant of such type of matrices. Now I will take some more examples of this matrix. So here I have taken one example, and it is said that we have to calculate that the determinant of the matrix. Now if you see this matrix, the matrix rows are in GP series. This is 1 3 3 square, that is it is in GP series with the common ratio 3. If you see the second row, this is also in GP with common ratio 2, and if you see the third row, it is also in GP with the common ratio 5. So in order to find the determinant of this type of matrix, we have to use this property, that is we just took the second column and then we applied this property, that is the last entry minus second last entry, that is 2, into the second last entry minus first entry, that is 2 minus 3, and x3 minus x1, that is 5 minus 3. So what will be the determinant of this matrix? 3 into minus 1 into 2, that is minus 6. So in this way you can determine the determinant of this type of matrices easily. So I hope you have you understood the concept of vondermonde matrix. Now I am going to take my next matrix. So the next matrix is Boolean matrix. Sometimes its question is also asked. So let a square matrix is said to be the Boolean matrix if entries are either 0 or 1. So in this type of matrices, you will see that the entries of the matrices are either 0 or 1. You will never take any non-zero element except 1 and 0. So if I take this kind of matrix or this kind of matrix or any matrix which consists of only two entries 0 and 1, that will be a Boolean matrix. So it is asked in competitive exam, that's why I am telling you, but it is not that important. Now we will discuss about the permutation matrix. About the permutation, I have discussed in the lectures of group theory. So if you have no idea about permutation, then you can watch there. Now I'm going to discuss permutation matrix, which is also a kind of Boolean matrix, because the entries that we take in that matrix are always 0 or 1. So the definition of permutation matrix is as follows: a square matrix with exactly one, I should write in words, exactly 1. That is, the 1 will repeat in each row and each column just for once. In each row and column and other elements are 0. That is, in each row and each column you will get 1 only for once, and other entries in that row and column must be 0. So if this kind of matrix is obtained, you will say that it is a permutation matrix. For example, we know about the identity matrix. If I consider a identity permutation, then what will happen? Let's see. So I am considering an identity permutation, that is 1 is going to 1, 2 is going to 2, 3 is going to 3. This kind of permutations are known as identity permutation. If I want to make the permutation matrix for this permutation, what will be that? Let's see. So what will be the permutation in this case? Here if you see, 1 is going to 1. So at the position A11 will get 1. And if you see, other two elements are not going to 1. So other elements become 0. Now we'll go for the second one. In this case, 2 is going to 2. So at the A22 position we'll get 1 and other entries become 0. And if you see the last one, 3 is going to 3. So at the A33 position we get 1 and other entries in that row becomes 0. So in this way we can find the permutation matrix. Now I am going to take one more example. This time I am taking a permutation matrix, and with the help of this we will form a permutation. So this is our matrix. Now if I want to make a permutation, then how we can make it? If you see, this is our first entry and this represents that 1 is going to 1. So this will be 1 is going to 1. If you see in the second row, 1 is present at the 2, 3 position. That is 2 is going to 3. So 2 is going to 3. And if you see third row, then 3 is going to where? Second position. So 3 is going to 2. So 1 is going to 1, 2 is going to 3, 3 is going to 2. That means it is a cycle of length 2. So this is 2, 3. And I have discussed about it. So these are the examples of permutation matrix. Similarly, if it is said that you just find the permutation matrix for this, then how you will approach it? So firstly, we will make the permutation. It is implying that 1 is going to 2, 2 is going to 3, and 3 is going to 1. If we want to make the permutation matrix of this permutation, how we can approach? We just take 1 is going to 2. It means that at the second position in the first row we'll get the 1 and other entries becomes 0. If you see the second row, this is 2 and it is going to 3. So here we get 1 and other entries become 0. If you see the last one, this is 3 and it is going to 1. So at the first position we are getting 1 and other entries become 0. Now if you see our definition, this is saying that in each row and column you will get one just for once. So here we have one only for once, and here only for once, here only for once. In column also one is repeating just for once. So these are satisfying the definition of permutation matrix. So I hope you learn about the definition of permutation matrix, vondermonde matrix, and Boolean matrix. So I hope you are liking my content. If you are liking my content, please subscribe my channel. Thank you.